Math 2, Unit 10, 10.1 notes. Okay, so today we're talking about exponents. The first thing that we want to make sure that you understand is, what does 5 to the second power actually mean? Very good. It means 5 times 5. Okay, so 4 to the third power means? Good. Okay, so I want you, through here, what they're saying is that if numbers have the same base, you can end up adding the exponents if they're multiplying. So we're just going to kind of make a note to ourselves because sometimes this sticks out more. So when you have the same base, and the terms are multiplying, you can add the exponents. So if you have a number, like how we are dealing with 5 to the second power, this number 5, that is the base. And the number 2, that is your exponent. Sometimes it's also referred to as a power. Okay, so the instructions next say, rewrite each expression using only one base. You do not need to work out the final answer. So, do you notice how these both have a base of 8 and they're multiplying? All we do is add the exponents. So in your notes, I'd like you to write out, we're going to go 8 to the 3 plus 6, and then we end up getting 8 to the 9th. I want you to write it out like this in your notes because I want you to see how we got 9. Okay? So on the next one, we would have 9 to the 6 minus 4 minus 2. Well, what is 6 minus 4? 2. And what is 2 minus 2? 0. So I have 9 to the 0 power. Does anybody know what that equals? 1. Very good. So as a note to ourselves, we need to remind ourselves is that anything to the 0 power equals 1. Bless you. And just so you understand why it is that way, if I have something like this, 5 divided by 5, what does that actually equal? It equals 1. Now, the exponent way, because this would be to the first power and the first power, and we're going to kind of talk about this later, but what ends up happening is when you're dividing, you end up subtracting the exponents. And so you would have 5 to the 1 minus 1, and 5 to the 1 minus 1 is 5 to the 0. Okay? And so what's happening is that actually all of the numbers are just canceling out and reducing to 1. Okay. On this next part, it says, when variable factors have more than one base, be careful to combine only those powers with the same base. So what I would suggest that you do is first start by multiplying numbers in front together, and then add powers of like bases. Mm-hmm. So if there's any right there on my desk, and there's always some that I have extra pencils over here. Okay, so what do I mean? Multiply numbers in front together. So do you see here how we have a 5 and a 3? Those are not exponents, so we're going to multiply those together. In fact, we're going to kind of write separate problems. So I'm going to write 5 times 3, and we know that 5 times 3 equals what? 15. Okay, then I have x's in here. Now, what happens when a variable doesn't have an exponent or a number? It's just a 1. So remember that, what would I put? No exponent equals 1. And so now I'm going to write this out. So we have x to the 4 plus 9 plus 1, which makes x to the 14th. So my answer is 15x to the 14th. Does anybody have questions on that? Okay, so try 4 on your own. Once you get an answer, check with somebody that you're sitting by and see if you guys agree.
Oh, wait.
Okay, so on this one, the 3 numbers that you're multiplying together should be -4 times 7 times 2, and what does that equal? -56.
How can you do 4 times 7 times 2 when C and D aren't the same?
So you end up putting like all the C's together, all the D's together, all the numbers together. So it's almost like you're like grouping everything in their groups. And so while I can't put C and D's together, numbers are all kind of in the same family. And so you can put all numbers that are in front together, and then all C's and then all D's. Okay, so then we go to the C's, and we have C to the 3rd and a -2. And what does that make? Just C. And you could write to the first power, but we know that if you don't have a first power, it's automatically 1. And then I just have D to the 2nd. And when you're working with letters, you want to always write them in alphabetical order. Okay, and so that means that this answer ends up being -56 C D to the 2nd. Do you have any questions there? Okay, number 5. Okay, so what are the numbers I'm going to multiply together on 5? Good, 5, 3, and 3. So 5 times 3 times 3 equals 45. Good. Then I'm going to go with my x's, and I have x to the what? Good. 5 plus 2, which makes x to the 7th. And then I just have y to the 6th. And so my answer is 45, x to the 7th, y to the 6th. Okay, any questions on this before we move on? Okay. So this next part we're talking about is powers to powers. What you'll notice is that here you have a power to a power, 4 to the 2nd power. Okay? Now what that means is that you really have 2 5 to the 4th powers. This is saying 5 to the 4th times 5 to the 4th. Okay? And if we go back to like our multiplying how we did before, we would end up going 5 to the 4 plus 4, which makes 5 to the 8th. So the shortcut, instead of writing it out like this, is just to multiply the powers to powers. So 4 times 2 makes 8. The other thing that you have to be careful of is that when you have parentheses, this fourth power is going to both the 3 and also to the x. Okay, so make sure you're bringing that, and that is a power, because this is really 3 to the first, and so if you multiply 1 times 4, you would end up getting that 3 to the fourth power. Okay, do we have questions before we start doing examples? All right, so number 6, all we have to do is multiply our power to power. So what is 4 times 5? 20. So x to the 20th power. Okay, number 7. Okay, same idea here. We're going to multiply 2/5 times 10, but I'm going to write this out. 2 over 5 times 10, and I can always make 10 as a fraction by putting it over 1. Yes, Denise.
On the example, how did it equal to 81?
To 81?
On the example?
Oh, they multiplied out 3 to the fourth power.
Oh, okay.
So we know 3 to the fourth power is 3 times 3 times 3 times 3. And you could go 3 times 3 is 9, 3 times 3 is 9, and 9 times 9 equals the 81.
Oh, okay.
Okay, so back to number 7 with the fraction. What are we going to do? Yeah, you can multiply across and simplify, or you can cross reduce if you want to. If I multiply across, I end up getting x to the 20 over 5, because 2 times 10 makes 20, 5 times 1 makes 5, and 20 over 5 reduces to 4. So my answer is x to the 4th. Okay, so don't be scared of fractions. Just make sure you write out the multiplication problem. Because when you look at it like this, it looks confusing. But if you write out the multiplication problem, that shouldn't be too bad. All right, number 8. What am I going to do here? Good, you're like distributing this to every term, right? And so this is going to make 7 to the 3rd power. And then we're going to have m to the 27th. And we are going to multiply this out. So 7 to the 3rd power means 7 times 7 times 7. Now, do you guys remember how to do this in your calculator without going 7 times 7 times 7? Okay, so you do 7. You can't see what I'm doing. Okay, 7. And then remember we use that like caret key. And then to the 3rd. And that makes 343. So my answer is 343 m to the 27th power. Questions on that before we move on? Okay. Number 9. Okay, so notice we have 2 separate sets of parentheses here. This 2 goes through whichever parenthesis it's touching. So this 2 is going through this parenthesis, and the only thing there is the x to the negative 2, and that makes what? Good, x to the negative 4. Now this parenthesis is touching the 4, and so the 4 goes to everything inside. So starting with, we're going to write 3 to the 4th. Now what's x going to become? X to the 4th, and then y will be y to the, good, because 5 times 4 makes 20. Now this is my only number in the problem, and the number always goes to the front. So in your calculators, if you type in 3 to the 4th, or you could even go back to that example that we had at the very beginning, what does 3 to the 4th equal? 81. Okay, so we have 81 for our numbers. Now, on the x's, we have x to the negative 4 plus 4. So what happens with that? It's x to the 0, right? Which cancels out, and it's just 1. So I have another number now, but what is 81 times 1? 81. And then I still just have y to the 20th. And so my answer is 81 y to the 20th. Okay, so these ended up making an x to the 0, which just cancels out. Okay? Is anybody confused by a part of this? We're good? Okay, so let's go to number 10. So since I have this parenthesis with the third power right here, I have to take the third power to everything in that parenthesis. So I'm going to keep everything else as it is because it doesn't have a parenthesis with extra exponents. And I'm going to take the third power to the 2, which makes 2 to the third. And I'm going to take the third power to j to the 11th, which makes j to the 33. And then I still have k to the 5th here at the end. So now let's separate it out, and we're putting everything together that's the same. So I start with my numbers. I have 4 and 2 to the 3rd. Okay? So we have 4 times 2 to the 3rd power. What is 2 to the 3rd power? 8. 2 times 2 is 4, times 2 is 8. And then 4 times 8 is 32. Good. Okay. Now let's move on. Alphabetical order. I would do what next? J's. Good. So we have j to the 2 plus 33, which makes j to the 35th. Good. Then we have our k's. I have k to the 6 plus 5, right? K to the 6 plus 5, which makes k to the 11th. And so my answer is 32, j to the 35th, k to the 11th. Do we have any questions?